Materials science bridges the gap between science and engineering. So we're using science to look at engineering materials. So for instance, in metals, we want to compare the mechanical properties of a material with the microstructure, and we use electron microscopes to look at that microstructure and try and understand how that influences the bulk properties of the material.
So where you see the white patches on that image up there, that's heavy elements, and where you see the dark... So instead of using light like people used to use in their labs at school, we use electrons. We're one of the most powerful electron microscopes in the world. The electrons allow us to look at materials at a very, very high resolution, so we can actually observe individual atoms or individual columns of atoms. The job that I do at the moment is incredibly varied because we have users come in with different samples and they want different sorts of results. So I actually get to look at everything from biological materials through to semiconductor materials and everything else in between.
The microscope is located in one site at Darsbury in Cheshire, and so we all travel to that site to use the microscope. Although having said that, we also have remote links. So for example, at this exhibition, we can actually see the images in real time that we're running from that site in Cheshire up to Glasgow.
We aim to push the frontiers of materials science, biology, trying to find out more about materials, how they're made up, and what the elements are within those materials.
It's an area where we're applying fundamental science to real engineering problems. So we're trying to link the microstructure to the bulk properties of materials, and so hopefully produce better new materials as well.